G'day, in this video we're going to be looking at displacement, velocity and acceleration again, but our core focus is going to be how to display these kinematic measurements graphically. So in terms of syllabus content, we're looking at 1.1, point 2 and 4. Module 1, still kinematics, still focused on inquiry question 1. We're going to begin to more directly address the graphical representation part of content point 2, which is looking at analyzing velocity. And further to that, we're broadening our understanding of our kinematic measurements and descriptions by visualizing what those measurements and descriptions look like in a graphical form. So our learning intentions, as I've already alluded to, is that we're going to develop our skills in being able to analyze straight line motion, and we're going to be using simulations and graphical representations to do that. The way that we're going to be able to get those graphical representations is through a PhET simulation. PhET is a STEM program run by the University of Colorado. They have all sorts of science-based simulations. This is probably not the only one that we'll be looking at within this course, but this one in particular allows us to analyze the position, velocity, and acceleration of a person as they are able to move in both directions in a straight line. You'll notice that we can adjust the position, velocity, and acceleration using this simulation, and that when we use it, we end up getting three different graphs. One which shows the change in position over time, so time on our x-axis, position on our y, the change in velocity as time progresses, and the change in acceleration as time progresses. I'm just going to spend a moment showing you some of the functionality of the simulation, and we'll spend most of our time in class playing around with it. So now that we're actually in the simulation, what we can do is begin to play around with some of our variables. First off, I can just show what happens if I change the position. We see that the person has changed their position to 3 meters. Because we haven't put any information about velocity or acceleration, there is no movement that is occurring. If we reset, pop in a position, maybe a velocity say, and hit play, what we'll see is that we're beginning to get some movement happening. In this case, velocity is constant, therefore we have a straight line. There's no acceleration that's happening, which means that there's no change in the velocity. But what we do notice is that there is a change in position, that is increasing over time. It's all sorts of combinations that we can have with our position, velocity, and acceleration. They will end up producing a variety of different graphs. So for example, I could have negative velocity, I could have a positive acceleration. What this is going to mean is that the person is going to start moving in the left-hand direction, but as the acceleration is positive in the right direction, eventually they're going to slow down, come to a stop, and turn back the other way. So we'll see that happening up the top, this slowing down, the turning, the moving, and as that's happening, we have all of these graphical representations here as well. So when we get into class, I'll have a few set activities for you to sort of run through. We might do some calculations associated with them as well, but we're going to be paying a lot of attention to what our graphs look like. That's going to give us the ability to begin to analyze this motion and hopefully as well get a better understanding of how these graphical representations can be used, interpreted, but also we'll be completing some practice questions with some other displacement time graphs, velocity time graphs, acceleration time graphs as well. Thank you very much. A short video today. But the purpose of today's video was just to get you familiar with the simulation that you'll be using in class. In the next video, we're going to be introducing an abstract but important concept known as frames of reference. We're going to be comparing two objects that are moving parallel to each other and doing some vector analysis and calculations with that. So I'll see you in the next video.